Hello, we are discussing wave optics. Wavefront is defined as the continuous locus of all the particles in a medium which are vibrating in the same phase. It is called wavefront. There are many types of wavefront. First one is spherical wavefront. When a source of light is a point source, the wavefront is there with the center of the source. There are two types of wavefront. One is diverging type, converging type, spherical wavefront. So if the point source is here, it is moving outward, and these are the diverging spherical wavefront. They are coming towards point. So these are the converging type spherical wavefront. It is diverging type, it is converging type. Now second, if the cylindrical wavefront, when the source of light is linear like tube rod, tube rod. Then all the points equidistant from the source lie on a cylinder. This wavefront is called cylindrical wavefront, like this. Third, plane wavefront. When the source of light at a very far off distance, like sun from the earth, very small portion of the sphere or cylinder appears to be a plane. Is called plane wavefront. Here in all the three cases, the wavefront and the rays, they are at 90 degree perpendicular to each other. This is true for spherical, cylindrical and plane wavefront all. So the rays are always normal perpendicular to the wavefront. According to Huygens, light energy flows along the rays. Here we can change the shape of wavefront from plane wavefront to converging or diverging spherical and vice versa with the help of concave mirror, convex mirror, lens, convex lens or concave lens. Like say these rays are coming here, this is the incidenting plane wavefront. After reflection it is converting into spherical wavefront. It is also spherical, but in this case it is converging type, it is diverging type. In lens also it is converging and diverging. So plane wavefront can be converted into spherical wavefront and vice versa also possible. Now Huygens principle. Here as per the Huygens principle, we can find out the future wavefront from the present wavefront. In other words, here how to find? Suppose this is the plane present wavefront. This is the present wavefront. On present wavefront, every point on the given primary wavefront, it is act as a fresh or new source of light or disturbance. This is called secondary wavelets. So these are the points here. They are the new source of the wave or sometimes wavelet for the next coming or future or forthcoming wavefront. These are moving in the same direction with the speed of light. From the new source, here drawing the arcs of the same distance as radius or distance is equal to velocity multiplied by time, taking that distance as radius of the arc and drawing the arcs here like, and on these arcs drawing the tangents, and by joining this all the tangential surfaces here, this is the locus, it's called future or forthcoming wavefront in the forward direction. So this is the Huygens principle. Now using the Huygens principle, we are verifying the laws of reflection. Let us say this xy is the reflecting surface like, and incidenting rays 1 and 2 coming here. AB is called incidenting wavefront, and again using the Huygens principle, from on the present wavefront AB incidenting wavefront, each and every point is treated as a new source of wave. Here considering point B and A dash distance, this is the velocity multiplied by the time. In reflection there is no change in the velocity, frequency and wavelength. In reflection also same speed. So BA dash distance equal to AB dash distance equal to CT. This is the arc, and from taking the point A, again drawing the arc of the same distance, and by joining the tangent here we are getting the B dash A dash is the reflected wavefront. This A dash B dash is the reflected wavefront, whereas AB is the incident wavefront. In these two triangles, triangle AB A dash and triangle A B B dash A dash. Angle this A B A dash and A B dash A dash both are 90 degree, and A dash in both the triangle is common. Now B A dash distance and A B dash distance we have constructed of equal distance. So these two triangles A B A dash and A B dash A dash are congruent triangles, and this angle B A dash and B dash A dash A are CPCT, congruent part of the congruent triangle. So this angle is I, angle I, this is R. This is the first law of reflection. And second, incident ray, normal and the reflected ray all lie in the same plane. This is the second law. So this way we have verified the laws of reflection using the Huygens principle. Now second, here using the Huygens principle we are verifying the laws of refraction. Here xy is the refracting surface separated the two medium, the air rarer medium and glass say denser medium. We know mu refractive index is velocity of light c upon velocity of light in the medium, that is say v. So C upon V is mu refractive index of the medium here glass. Again AB is the incident wavefront and A dash B dash is the refracted wavefront. Here BA dash the distance traveled by the light in air with the speed of light c. So BA dash is equal to what? CT, but in the next medium, denser medium, that is the glass here, speed is reduced V. So AB dash distance is VT the same time, but distance is lesser because V is lesser than C, the medium. Now in this triangle AB A dash and A B dash A dash, sin I is equal to what? Perpendicular upon hypotenuse. Similarly, sin R is equal to this perpendicular A B dash upon the hypotenuse A dash. If we divide this here, sin I upon sin R, it is giving here, putting the value of B dash upon A dash, A B dash upon A dash. This cancel out here. We are getting B dash upon A B dash, CT. T cancel out. C upon V, that is the mu. So we get mu equal to sin I upon sin R. This is the Snell's law or first law of refraction. Here incident ray, normal and the refracted ray all lie in the same plane. This is the second law. So here laws of refraction also verified. Here in both the same verification asked 2 or more times, but ray is now moving from denser to rarer medium. If we verify this by using this figure is wrong because the ray is moving from denser to rarer medium. It is a denser medium, say glass, to the rarer medium, say air. This is the incident ray, and here AB is the incident wavefront and A dash B dash is the refracted wavefront. Here BA dash again it is what? BT and AB dash is CT. Here C is more in air, B is less in glass. So here sin I upon sin R, B A dash upon A dash, AB dash upon A dash, this cancel out here. BT, V by C is 1 by mu, is 1 by mu. So mu is equal to what? Sin R upon sin I. In denser to rarer medium, mu is written as sin R upon sin I, whereas when the ray is moving from rare to denser, it is called sin I upon sin R. In the absolute term, like this, reverse ho jata hai. In relative term, mu air, because the ray is moving from denser to rarer air from glass. So mu of air upon mu of glass is sin R upon sin I. Mu of air is 1. Of glass, reverse kar denge. We are getting this same thing here. This is Snell's law. So this is the first law here also. Second, incident ray, normal and the refracted ray all lie in the same plane. So this is the second law. Laws of refraction is also verified when the ray is moving from denser to rarer medium. Now very important, say coherent sources of light. The sources of light emit continuously light waves in the of the same wavelength, same frequency, and having the zero or constant phase difference. They are called coherent sources. In superposition, if crust and crust, we are getting the bigger crust, trough and trough, we are getting the bigger trough. So amplitude is increased when the phase difference is 0. Or intensity is directly proportional to amplitude square. So intensity also increases. Whether crust is bigger crust, trough is bigger trough, in both the cases amplitude is increased. If the amplitude of two waves are different, even then we are getting the bigger crust and bigger trough, means intensity is more, energy is more, amplitude. On the other hand, if the phase difference is 180 degree, just a position, crust and trough, we are getting the zero amplitude. If their amplitude intensity is same, if amplitude intensity are different, then resultant will be lower crust of a smaller amplitude. And suppose trough is more, we are getting the lesser amplitude trough. So here amplitude and intensity decreases after the superposition. Now interference. Interference, here this is the phenomena due to the superposition of waves from two coherent sources. We get a spectral pattern of bright and dark fringes on screen alternately of equal intensity and equal spacing. This is called interference. Mathematical or analytical method of the superposition principle using in interference. So mathematically, let us say we consider here two waves from the two coherent sources of monochromatic light, preferably that the single wavelength or single frequency. Here taking the two waves, y1 is equal to a sin omega t and y2 is equal to b sin omega t plus phi, where y1 and y2 are the instantaneous values. A is the amplitude maximum value of wave number 1 and b is the amplitude of wave number 2, and here phi is the phase difference between the two, that is constant. So they are y1, y2 are coherent sources. So phase difference 0 ho ya constant ho. Now using the superposition, y is equal to y1 plus y2, y1, y2, opening this, using this formula, sin a plus b sin a, cos b plus cos a sin b, using it here. So this is sin omega t cos phi plus cos omega t sin phi, using this formula. Now from this and this we are taking the common sin omega t in bracket, remaining a plus b cos phi and cos omega t b sin phi. Assuming here r cos theta is equal to a plus b cos phi and r sin theta is equal to b sin phi. Putting the equation 2 and 3 in equation 1, this is equation 1 here, sin omega t, and here की जगह हमने क्या लिखा, r cos theta, इसकी जगह r sin theta, taking r common, sin omega t cos theta plus cos omega t sin theta, using this same formula again. It is sin a plus b. So final wave is y equal to r sin omega t plus theta. Theta is the ultimately phase difference and r is the amplitude of the resultant wave. We can find out the final phase difference theta just by equation 3 by 2. Dividing this, we are getting or cancel out tan theta is equal to this. So theta will be tan inverse. So this way we can find out the phase difference. And now finding the amplitude r. This equation 2 and 3, now squaring and adding of these two equations, here we get squaring and adding r square common, cos square theta plus sin square theta, a square plus b square cos square phi and 2ab cos phi plus इसका करेंगे तो b square sin square phi. Now cos square theta plus sin square theta, that is 1. Here also taking b square common, this is also 1. Finally r square will be a square plus b square plus 2ab cos phi and r will be root of this given by equation. This is the amplitude of the resultant wave r. Now we know intensity is directly proportional to amplitude square. So I directly proportional to r square, resultant wave. I1 first wave directly proportional to a square and I2 is directly proportional to square. If we put it here, then I1, I2 and 2 root I1, root I2 cos phi. So equation 4 and equation 5 are respectively amplitude and the intensity of the resultant wave. Now for bright fringe, intensity or amplitude maximum, bright or constructive interference. Sometimes it is called constructive interference, maxima or bright fringe. R maximum, I maximum, when the cos phi is maximum, that is plus 1, so general value of phi is 2 and pi, Here n is equal to 0, 1, 2, 3, 4. In general, this is the phase difference, and the relation between phase difference and the path difference given by this. This is the one cycle of the wave. This distance is called wavelength. In angle 2 pi radian, 360 degree, or this is the time period. So lambda and 2 pi related like this. When 2 pi radian phase difference, path difference is lambda, it is 1, lambda by 2 pi. If the phase difference is phi, the path difference 1 by lambda upon 2.25. So this is the relation. Using this relation here, path difference for the bright fringe are maxima given by using this formula here, lambda upon 2.5, phi is what 2 and pi. So 2 pi cancel out. This is the path difference in general, and this is the phase difference in general. Must learn. बहुत useful है numericals में, conceptual हर जगह. Now for dark fringe or minima, or sometimes it's called destructive interference, R minimum, I minimum, when cos phi is the minimum value minus 1, general value is 2n minus 1 pi. We have modified this general value. The reason behind here, n is equal to 0 not possible for dark fringes because center में bright fringe है, dark नहीं. So n is equal to 0 is not valid in case of dark. Here general value of pi phase difference 2n minus 1 pi. Using this relation here, path difference for dark fringe lambda 0.5, phi की value put कर दी. So this is the path difference for dark fringe, and this is the phase difference for dark fringe. Again we have to learn it. Now for minimum, putting the value of cos phi minus 1, a square plus b square 2 minus 2 अभी रूट है, इसे सॉल्व करेंगे तो a माइनस b हो जाएगा. I मिनिमम कितना होगा, i1 प्लस i2 माइनस हो जाएगा, cos phi की वैल्यू माइनस 1 है, तो हम ऐसे लिख सकते हैं रूट i1 माइनस रूट i2 और ब्रैकेट में होल स्क्वायर. So it is true for r minimum, I minimum, and here is I maximum and r maximum. Now very special case here, when the amplitude of the two waves or the intensity is same, then r maximum will be a plus b. a plus b है तो हम इसे 2 ही लिख लेंगे. i1 i2 इक्वल है तो हम इसे ऐसे लिख देंगे 4i1, एंड मिनिमम में a माइनस a 0 एंड रूट i1 i2 सेम ही है. तो ये स्पेशल केस में एम्पलीट्यूड विल बी डबल एंड इंटेंसिटी विल बी 4 टाइम्स, एंड मिनिमम में दोनों 0 हो जाएगा. दिस इज द बेस्ट कंट्रास्ट. ब्राइट एंड डार्क का कंट्रास्ट इस मैक्सिमम आ रहा है, तो मैक्सिमम मिनिमम का बेस्ट कंट्रास्ट है व्हेन दिस इज स्पेशल केस. Here amplitude and intensity both are equal. Suppose we are taking i1 i2, they are same. Let I naught in this formula here, i1 plus i2 2 root i1 i2 cos phi. i1 i2 का हमने i naught लिखा तो i naught plus i naught 2 root i naught cos phi. यहाँ पे हमने 2 i naught कॉमन ले लिया, ये आ गया. Using the half angle formula, cos 2 alpha is equal to ये होता है हाफ एंगल फॉर्मूला. अगर यहाँ पे 2 अल्फा की जगह 5 होगा तो हाफ एंगल आ जाएगा 5/2. ये 1 इधर जाएगा तो 1 प्लस cos 5 को हम 2 cos स्क्वायर 5/2 पुट करेंगे. यहाँ पे पुट कर दिया इसकी जगह तो 2 टू द 4 हो गया. फाइनल रिजल्ट मिल गया है. इंटेंसिटी रिजल्टेंट इंटेंसिटी 4i naught cos 5/2. ये सिर्फ तभी पॉसिबल है व्हेन i1 i2 बोथ आर सेम, अदरवाइज ये फॉर्मूला वैलिड नहीं है. नाउ इफ द विड्थ ऑफ द स्लिट्स I say W1 and W2 are the width, then intensity I1 I2 amplitude A1 A2, then this is the relation. ज़्यादा width होगी उतनी ज़्यादा light जाएगी, उतनी ज़्यादा intensity होगी. So W1 by W2 is equal to I1 by I2 is equal to A square by B. Hello, this is question asked again in the board. In interference, energy or intensity is conserved. We have to prove it. Means there is no loss of intensity and energy during the interference. So in the interference pattern, we take the I maximum and I minimum cos phi plus 1 है, जब cos phi minus 1. तो एवरेज कैसे निकलेगा, I average I maximum plus minimum upon 2. पुट कर देंगे यहाँ पे मैक्सिमम मिनिमम को, ओपन करके ब्रैकेट को, ये कैंसिल हो गया तो 2 टाइम्स 2 भी कैंसिल होके ये मिल गया एवरेज वैल्यू. एंड बिफोर सुपरपोजिशन इंटेंसिटी थी पहले की दूसरी I1 I2. तो I1 प्लस I2 पहले भी वही है, बिफोर सुपरपोजिशन आफ्टर सुपरपोजिशन. बिफोर इंटरफेरेंस एंड आफ्टर इंटरफेरेंस intensity same, energy same, so means there's no loss of intensity, there's no loss of energy, it remains the same. This is the conservation law applied here. So in interference, intensity of light is simply being the redistributed from the dark bands to the bright bands. So neither energy created here nor energy last. Now we are deriving the expressions of fringe width. Fringe width expression. What is the fringe width? First of all, defining this. Fringe width beta is defined as the gap or the distance between the consecutive bright fringes or consecutive dark fringes. Say in this figure, these are A and B are the slits, is the gap between them, and capital D is the gap between the slits and the screen. So this is D is the center point on the screen, d by 2, d by 2. Let us say from the center, this is the x. X is the distance of particular fringe at point P. So here PF distance हो जाएगा x plus d by 2. Similarly, PE distance हो जाएगा x minus d by 2. This is x plus. The part difference here is BP minus AP. BP में से AP minus करेंगे तो हमें part difference BN मिलेगा. Given by equation 1. And triangle BPF using the Pythagoras theorem, PP will be this base PF and this PF perpendicular. तो हमने put कर दिया BF की जगह D, एफ की जगह एक्स प्लस डी बाई 2 हियर एंड रूट ऑफ इट. ऐसे डी कॉमन ले लेते हैं. डी स्क्वायर कॉमन लेंगे तो ब्रैकेट के बाहर डी आएगा 1 प्लस एक्स प्लस डी बाई 2 होल स्क्वायर अपॉन डी स्क्वायर. Using the binomial theorem, 1 plus y to the power n is equal to 1 plus n y. Y is very small. Using it here, this n 1 by 2 यहाँ जाएगा. This is BP. Similarly, AP यहाँ पे x minus d by 2 होगा. तो equation 2 BP, equation 3 AP. अगर हम इसको equation 1 में पुट करेंगे, इसमें क्या मिलेगा हमको? Part difference will be BP minus AP. कर दिया equation 2, 3 से दोनों वैल्यूज 1 कैंसिल हो गया. इसमें कॉमन ले लिया. डी स्क्वायर एलसीएम आ गया. इस ब्रैकेट को ओपन करते हैं. प्लस बी होल स्क्वायर वाला फॉर्म एक्स स्क्वायर प्लस डी स्क्वायर बाई 4 प्लस एक्स डी माइनस कैंसिल आउट. एक्स डी विल बी 2 एक्स डी. एक डी कैंसिल हो गया, 2 भी कैंसिल हो गया. फाइनली पार्ट डिफरेंस का फॉर्मूला मेरे को मिल गया ये वाला. एक्स कैन बी रिटन एज क्रॉस मल्टीप्लीकेशन डी बाई डी डेल्टा. वेयर एक्स इज द पोजिशन ऑफ द पर्टिकुलर फ्रिंज फ्रॉम द सेंटर ऑफ द स्क्रीन एक्स एंड दिस इज द पाथ डिफरेंस. No, so this is the equation. Finally, we get position of the particular fringe from the center. Now, considering here the bright fringes, part difference होगा n lambda. यहाँ पे हम जनरल लेंगे थर्ड माइनस सेकेंड और सेकेंड माइनस फर्स्ट और 10th माइनस 9 और फर्स्ट माइनस सेंटर. यही हो जाएगी डेफिनेशन के हिसाब से फ्रिंज विड्थ. In general, we are taking xn minus xn minus 1. nth bright fringe minus n minus 1th bright fringe. तो पुट कर देंगे यहाँ पे n की जगह n minus 1. सॉल्व करके यार बेटा the expression of fringe width. Now take considering the dark fringe. Dark fringe का फॉर्मूला क्या होगा? पार्ट डिफरेंस होता है 2n minus 1 लैम्डा बाई 2. n की जगह n minus 1 लिख देंगे. यहाँ डिफरेंस अभी भी यही आ रहा है. मतलब चाहे हम डार्क लें चाहे ब्राइट लें, डेफिनेशन भी यही है. The fringe width is defined as the gap between the consecutive bright or consecutive dark. Same distance आ रही है तो फॉर्मूला भी सेम हो गया. तो फाइनल फॉर्मूला इज दिस. फ्रिंज विड्थ का फॉर्मूला हो जाएगा d by d लैम्डा एंड एंगुलर विड्थ हो जाएगी इसकी लैम्डा बाई d. दिस इज द लिनियर विड्थ, दिस इज द एंगुलर विड्थ. क्लियर. ये क्वेश्चन जो हैं बहुत बार आते हैं बोर्ड में, रिपीटेड क्वेश्चन. अगर इस फॉर्मूले में हम डी को इंक्रीज करेंगे, बीटा इंक्रीज होगा. इस स्मॉल डी को डिक्रीज करेंगे तो भी इंक्रीज होगा. लैम्डा को यानी वेवलेंथ इंक्रीज करेंगे तो भी ये इंक्रीज होगा. सपोज वी आर टेकिंग द रेड मोनोक्रोमेटिक लाइट इंस्टेड ऑफ ब्लू light, then wavelength of red color is more than the blue waveguide. So wavelength is more, beta increases here by taking the red color instead of blue color. ये वाला क्वेश्चन बहुत बार आता है. This question in YDSE young double slit experiment, शॉर्ट में YDSE. तो अगर डिप करते हैं, सबमर्ज करते हैं in water, then what will happen with fringe width? If the whole apparatus is submerged in water, then what about the beta? Beta is given by d by d lambda. Capital D small d में no change. बॉटम डालने से क्या चेंज? But wavelength will definitely change. It is decreases by a factor of mu of water. So lambda in water will be lambda upon air, lambda air upon of water. So beta will be the water, beta air upon mu of water. So fringe will decrease by a factor of mu. Now this is the question here. Again, when time asked this, if we take the white light instead of monochromatic light, then taking the white light में there are 7 color waveguide. So Here all the colors are reaching at the center. So they are mixed. The central will be the bright fringe. It's white in color, but other fringes, all the colors are not equally. So it will not be the white, it will be the colorful. So other fringes will be colorful. Center will be the bright fringe. In the colorful fringes, center of the colorful fringes will be the red, the least deviated because of the red color, and the extreme color most deviated than the violet color. So this way other fringes will be colorful. Now another topic which is also very important, that the fringe shift when one path is obstructed by the transparent sheet of thickness let's T and medium here is mu. Refractive index of the medium of this thin sheet. Let x is the position of the particular fringe at P from the center O, and after putting the transparent sheet, let us say this edge is shifted towards that side where obstruction is there. So the same fringe that nth bright is shifted upward at point P dash from P. So what is the fringe shift? X dash minus x is the fringe shift, x dash minus x. After the introduction of the transparent sheet of thickness T and refractive index mu. Here formula of fringe, position of the fringe we know. This is the x equal to position d by d, and this is the lambda original part difference. So this is the position of the particular fringe without transparent sheet. Now we have introduced the transparent sheet. The position is x dash given by d by d part difference original plus, because of this transparent sheet, extra part difference. It is given by original distance minus the effective distance mu t. Distance तो t है, effective distance increase. So mu t minus t is the effective extra part difference. Suppose this is the equation, say t common ले लिया हमने. So x dash will be d by d. This original part difference, this is the extra part difference. So fringe shift will be x dash minus x, putting the value from equation 3 x dash and this equation 2. After putting them here, d by d common, delta plus this extra part difference minus original from equation 2. This is cancelled out. We are getting fringe shift is equal to d by d mu minus 1 into t. Now we know the expression of fringe width. Beta is equal to d by d lambda. So d by d is equal to what? Beta by lambda. We put it here. Either by equation 4 or equation 5, we are getting the expression of fringe width. So from equation 4 and 5, fringe shift depends on these factors. Now, very important point. The question भी अक्सर बोर्ड में पूछते हैं. This is the condition for sustained interference. Two sources must be coherent. Amplitude and intensity are preferably equal, so that we are getting the best contrast as we have discussed earlier. Sources should be monochromatic. अगर monochromatic नहीं लेंगे तो white light जैसा आ जाएगा, intermix हो जाएंगे. This all pattern, 7 pattern will be intermix. So sources must be monochromatic, single wavelength or single frequency. Sources should be very close, and this gap between them is slits small. Two sources should be point size and very small. So slits should be very thin. Now we are discussing the different phenomenon, that is the diffraction of light. Diffraction of light is the phenomena of bending of light around the corners of an obstacle or aperture in the path of the light. This aperture should be very, very thin in case of light. In case of sound, is even more, even then, because of it depends on the wavelength, and wavelength of the sound is quite large. So by the large aperture, sound can bend. But for light, wavelength is very, very small. So the slit width should be of the order of wavelength, and that is the micron level, 10 to the minus 6 meter. So this is the necessary condition here. Slit width should be less than or equal to 1.5 lambda. Here, these are the waves coming here. The parallel waves means plane wave front. After passing through the single slit, very small. In figure, you can say it is large enough, but practically it is very, very small, of the order of micron level. So this is the screen here, and this is the gap D, capital D here. It is bending from the corners. So at point P, all the waves are reaching at point P at a distance of x from the center of the screen, and BP minus AP is the path difference. Bn is equal to what? Is delta path difference. Theta, this is also theta. So here on the screen we are getting this pattern is different than the interference pattern. In interference pattern, all the bright fringes of the same intensity, but here central bright fringe intensity is very large, but the secondary fringes intensity is decreasing, like I0 by 22, I0 by 61, I0 by 121. It is a typical value, not the fixed. Normally, so this both side intensity decreases and width also decreases. With intensity both are decreasing as we move from the center away from both sides from the center. So diffraction pattern obtained on the screen consists of a central bright fringe having alternately dark and bright fringes with a decreasing intensity both sides, and secondary waves are equidistant from center C, CA and C. So here A and CB, they are equal, as you can see in the figure also. They travel the same distance, each O, the center of the screen. So there is no path difference 0. So resulting is the maximum intensity at point O, I0. Let us consider here the wave traveling in the direction making different. Say here, this is the direction at point P, taking in term. So what will happen here? The path difference, as we can see in the figure, this is the figure here, this is the figure A, B, and this triangle we are taking here, like this. So this A is what? Is the slit width, and this is the path difference. Sin theta is equal to perpendicular path difference upon hypotenuse A. So path difference is given by Bn AB sin theta. AB is what? Slit width A. So delta is equal to A sin theta. If the path difference is lambda, then P point will be the point of minimum intensity. This is called dark fringe. This is because the whole wavefront AB is divided into two parts. The first part here, this is the second part. If the lambda is the path difference, this will be separated by, so this is lambda by 2. And lambda by 2 considered from the interference. Suppose they are interfering, these two waves are interfering, path difference is lambda by 2, it will be dark. This also, so first part, second part आपस में मिलके dark fringe. दिस इज कॉल्ड फर्स्ट मिनिमा. देख रहे हो आप, इंपॉर्टेंट बात है. इंटरफेरेंस पैटर्न में यहाँ एन लैम्डा क्या मिलता था हमको? एन लैम्डा मिलता था हमको ब्राइट, क्या मिल रहा है? उल्टा डार्क. इज द अपोजिट ऑफ द इंटरफेरेंस is the case of bright fringe, but here we are getting the dark fringe in interference के लिए bright है, फ्रैक्शन के लिए यही चीज dark. पार्ट डिफरेंस sin theta will be n lambda by 8. सपोज ये अगर पार्ट डिफरेंस 3 lambda by 2 हो, तब दिखेंगे हम लोग इसको स्प्लिट को हमने 3 पार्ट में डिवाइड कर दिया, 1 2 3. दिस इज पार्ट डिफरेंस 3 lambda by 2. सिमिलर ट्राइंगल्स का रेशियो ले लेंगे, दिस विल बी lambda by 2 lambda, and this is also lambda by 2 lambda by 2 lambda. So lambda by 2 and lambda by 2 plus lambda by 2 is lambda, plus lambda by 2 is 3 lambda by 2. फर्स्ट पार्ट को अगर सेकंड से देखेंगे, पार्ट डिफरेंस इज lambda by 2. ये दोनों मिलके क्या देंगे? फर्स्ट एंड सेकंड पार्ट विल बी डार्क. ओनली थर्ड पार्ट विल गिव यू दी ब्राइट फ्रिंज. इंटेंसिटी पूरे स्लिट की 1/3 से भी कम आ रही है, so it will be bright fringe with less intensity. Intensity कम हो रही है, roughly I0 by 22. Where I0 is the intensity of the central bright fringe, central maxima. Here only third part. भी एक्सट्रीम छोड़ दें तो और भी कम, इंटेंसिटी इसलिए काफी कम हो गई. Similarly for fringes, if we are moving from away from the center, intensity decrease हो रही है, like we have seen here. This case I0 by 22, I0 by 61, I0 by 121. Like यही पार्ट है कि कुछ आपस में कैंसिल हो रहा है. वी हैव nth मैक्सिमा पार्ट डिफरेंस ये sin थीटा इज इक्वल टू व्हाट, ये वाली कंडीशन. ये देखिए कौन सी कंडीशन थी, ये इंटरफेरेंस में डार्क की थी, बट यहाँ मिल रहा है ब्राइट. sin थीटा इज गिवन बाय दिस. फॉर सेकेंडरी फ्रिंजेज अदर देन द सेंटर, पोजीशंस ऑफ ब्राइट एंड डार्क फ्रिंजेज एक्सचेंज, इंटरचेंज इन डिफ्रैक्शन इन कंपेरिजन टू इंटरफेरेंस पैटर्न. पहले देखा था डार्क ब्राइट बन गई, ब्राइट डार्क बन गई उस पोजीशन में. So they are interchanged in comparison to interference. Very important point. Note please. Now, width of the central maxima. Let us say this is the slit, and we are considering only the central bright fringe. Central bright fringe. Here, the extreme point must be dark. First dark this side, first dark opposite side. In between we are getting the central bright fringe. So here dark first and dark first here. This angle 2 theta is called angular width, and where 2x is called linear width. From this triangle you can find out theta. A sin theta is equal to what? 1 lambda. First dark. So sin theta is lambda by a. Theta is very small, so it is replaced as sin theta को हमने theta में change कर दिया. Theta is lambda by a. But 2 theta is the angular width of the central maxima. So this is the formula. 2 theta is equal to 2 lambda by a. Put the value of theta. And x upon d, the tan theta. So again theta is small. तो थीटा की जगह tan थीटा की जगह थीटा लिख सकते हैं. X will be d theta and linear width will be 2x. 2x की जगह d theta. In the value of theta here, like so, this is the linear width of the central bright fringe given by 2 d lambda by a, and this is the angular width of the central bright fringe is 2 lambda by a. The difference between the interference and the diffraction, this is the due to the superposition of the two distinct waves coming from the two coherent sources. Here coherent source is a must. Double slit experiment. This is the single slit experiment. Coherent source no need. The superposition of waves coming from the different parts of the same wavefront. Same wavefront. ना two slit नहीं, एक ही wavefront का हमने उसके parts आपस में superimpose कर रहे हैं. वैसे में डिफ्रैक्शन पैटर्न मिल रहा है. इन इंटरफेरेंस वी आर गेटिंग लाइक दिस तरह का पैटर्न मिलता है हमको, वेयर वी आर गेटिंग हियर इंटेंसिटी एंड विथ डिक्रीजिंग बोथ साइड्स. सेंट्राइज्ड साइड इंटेंसिटी एंड विथ डिक्रीजिंग, बट हियर इन intensity same for all. Right, that is better. So the difference here, interference and the diffraction. All bright fringes of equal size, equal intensity, but here intensity is decreasing, like with also decreasing. Position of dark and bright fringes are opposite as in case of interference. We have इंटेंसिटी मिनिमा इज जीरो और वेरी स्मॉल. जीरो तब होगा जब ये इंटेंसिटी सेम होगी, एम्पलीट्यूड सेम होगा. यहाँ पे इंटेंसिटी जीरो नहीं होता, कुछ होगा जरूर, जीरो नहीं होगा. फ्रिंज विड्थ इज जनरली इक्वल, हियर इट इज फ्रिंज विड्थ इज डिक्रीजिंग बोथ साइड्स. नाउ फ्रेजनल डिस्टेंस, दिस इज द मिनिमम डिस्टेंस. फ्रेजनल डिस्टेंस इज द मिनिमम डिस्टेंस ऑफ ए बीम ऑफ लाइट कैन ट्रेवल बिफोर एंड deviation for straight line path. The ray optics, due to the diffraction, it is wave optics because it becomes significant or noticeable. यानी ये वेव जा रही है, हल्का सा बैंड होना दिख जाए आपको, सफिशिएंटली दिख जाए, नोटिस हो जाए, उस डिस्टेंस को बोलेंगे हम डिफ्रैक्शन. फ्रेजनल डिस्टेंस, जब डिफ्रैक्शन हमको दिख रहा है, नोटिस हो रहा है, उस डिस्टेंस को फ्रेजनल डिस्टेंस गिवन बाई a square by z, where a is the slit width, lambda is the wavelength. Now resolving power. Resolving power of the instrument or eye is the power or ability of the optical device or instrument, eye also, to produce distinctly their separated images of the two very close spaced objects. जितना हम क्लोज डिस्टेंस को सेपरेट कर पाएंगे उतनी ज्यादा रिजॉल्विंग पावर ज्यादा होगी. So this is the minimum distance between the two objects which can just seen separately by the optical instrument. This is called the limit of. कम डिस्टेंस को हम सेपरेट कर पाए, वो उसी की लिमिट. जितनी कम करेंगे उतनी ज्यादा पावर हो जाएगी. पावर एंड द लिमिट ऑफ रिजोल्यूशन दे आर रेसिप्रोकल to each other. In microscope ये फॉर्मूला याद रखने और लर्न करना है. जस्ट लिमिट ऑफ रिजोल्यूशन इज गिवन बाय लैम्डा अपॉन 2 म्यू sin थीटा. लिमिट ऑफ रिजोल्यूशन इज 1.2 लैम्डा अपॉन डी. रिजॉल्विंग पावर का फॉर्मूला ये हो जाएगा d अपॉन 1.2. उल्टा है लिमिट ऑफ रिजोल्यूशन का रेसिप्रोकल है, पहली बात किया था, इसका उल्टा कर देंगे. वेयर d इज कॉल्ड डायमीटर ऑफ द ऑब्जेक्ट, हियर थीटा इज का कोन एंगल ऑफ द light entering the object of the lens of the microscope. Objective lens of the, formula याद ही रखो.